Graphing linear equations from a function table. All right, well, this is what a function table looks like. It's also, some people refer to it as an input-output table. And I actually have another video on functions that you might want to watch where I discuss actually what a function is. So we're going to take this equation, y equals x plus 2, and we're going to graph it. So the first thing we're going to do is we're going to give some values to x and y. So x is our independent variable. It's our input. So I'm going to start with 0. I'm going to give x a value of 0. So y would equal then, if we replace the x with 0, 0 plus 2 is 2. The value then of y would be 2. So we're going to graph 0, 2. You can use any values you want. It's probably best to use whole numbers, integers. So I'm going to use 1, 2, 3. I'm going to keep it simple. Plus I want to make sure the points fit on our graph. So if I replace the x with 1, y would equal 1 plus 2. So y would have a value of 3. So the ordered pair would be 1, 3. Because this, if x is 0, then y is 2 in this first example. If I replace x with 1, y has a value of 3 in the next example. All right, we're going to use 2. We're going to replace the x with 2. So y would have a value of 4. And the ordered pair, again, would be 2. If the value of x is 2, the value of y would be 4. And let's just do one more point. You probably could graph it just using these 3 points, but we'll do one more. So if the value of x is 3, I'm going to replace x with 3. The value of y, your dependent variable, would be 5. And the order pair would be 3, 5. Now this is the fun part. So we're going to plot these points, and then we're going to see if we can make a line from the points. So 0, 2 is first. I'm going to run 0, jump 2. Our next point is 1, 3. I'm going to plot that, so I'm going to run 1, jump 3. Then we have 2, 4, so I'm going to run 2, jump 4. And our last point is 3, 5, so I'm going to run 3, jump 5. And I'm just going to go ahead and do this freehand. Just going to make our line here. So this line represents the equation or the function y equals x plus 2. And this line, of course, goes on forever in both directions, and any point on that line would be a solution to this equation. All right, let's do one more. So here we're going to graph y equals 2x plus 1. So we're going to give x some values. And again, to keep it simple and to make sure it fits on my graph, I'm going to use whole numbers, and I'm going to keep them relatively small. Okay, if I give x a value of 0, then y would be 2 times 0 plus 1. 2 times 0 is 0, plus 1 would be 1. So y would have a value of 1. So if x is 0, y would be 1. I'm going to replace x with 1 to determine the value of y. So I'm replacing the x with 1. 2 times 1 is 2, plus 1 is 3. So if x is 1, then y would be 3. All right, we'll do 2 more points. If I replace x with 2, if I give x a value of 2, it would be 2 times 2 plus 1. Y would have a value of 5. So if x is 2, y is 5. And again, the first ordered pair is the first number in an ordered pair is the x, and the second is the y. And last but not least, I'm going to replace x with 3. Y would then have a value of 7. So if x is 3, then y would be 7. I'm going to quickly graph these. So 0, 1 is our first point. Run 0, jump 1. And then 1, 3. Run 1, jump 3. And then I'm going to plot the next point right here, 2, 5. So I'm going to run 2, jump 5. And last but not least, 3, 7. So I'm going to run 3, jump 7. And I'm going to connect those points. And these are called linear equations because they form straight lines. And this linear equation would be y equals 2x plus 1. This is y equals 2x plus 1. So piece of cake. That's all there is to graphing equations.